Question 3 says, suppose a company makes ID cards that consist of 3 letters followed by 4 digits. How many possible IDs are there if the letters can repeat but the numbers cannot? So if we think about an ID card, well, when we're doing this, right, it's got 3 letters followed by 4 digits. And if we think about it, the important part with the ID would be the arrangement of those letters and digits. So really we'd have to view every single letter and every single digit as its own event, since the different spots would really be the key information here. So really what we'd have is we'd have like letter 1, letter 2, letter 3, and then at that point we switch over to digits. So then I'd have like number 1, number 2, number 3, and number 4. So there's 7 events. And let's look at what goes in each blank. So if we think about how many letters are possible, there's 26 letters in the alphabet. So we would have 26 possibilities for the first one. And then notice what it says about the letters. It says the letters can repeat, which means even if I used a letter in the past, I can reuse it again. So my options is not going to decrease. So like for letter 2, I also have all 26 letters possible. And same for letter 3, all 26 letters are possible. But then it says that the numbers cannot repeat. So first off, the total number of digits, we've got 0 through 9, so there's 10 options. And then when I get to my next number, I can't use the same number again, so we're going to decrease to having only 9 options. And then once we get to the third one, we're down to only 8 options, and then only 7 options for the last digit. And what we're doing with these events is we're doing sequential counting. So that says multiply the numbers together. Sometimes people would think about this problem as 2 separate events first. So first find the letters and then find the numbers and then put those 2 things together, which is fine. But you have to remember when you put those together, you still do put them together with a multiplication. So in the end, everything is multiplied. So we've got 26 times 26 times 26 times 10 times 9 times 8 times 7. So we've got 88,853,040. So over 88 million possibilities, which is pretty good. Because if you think about what you want for ID numbers, you'd want lots and lots of different possibilities so you can create unique ID numbers for every single person. So then let's think about, and then part B, now it says the letters cannot repeat and the numbers can. So not a whole lot different, but we're going to have some tweaks. We still, though, have letter 1, letter 2, letter 3, and then number 1, number 2, number 3, number 4. Oops. 2. Here, let's just erase it and I'll draw it again. So then let's fill in how many things we have for each of those. So for the first letter, again, there's 26 letters in the alphabet, so all of those would be possible. Now this time the letters cannot repeat, so I can't use the same one. So now when I get to letter 2, I only have 25 options possible. And letter 3 would only have 24 possible. Now we're switching to numbers. So again, the digits are 0 through 9, so there's 10 options. And the numbers this time can repeat. So I could say use the number 5 multiple times. So even though I picked a number first for number 1, I can use the same one again if I want. So my pool of options is still the same. We still have all the digits 0 through 9 for each of these. And then we're going to multiply all the way across for sequential counting. So now we've got 26 times 25 times 24, and then we had times 10 times 10 times 10 times, oops, I missed a, here, let me clear it out. Start again, 26 times 25 times 24 times 10, 10, 10, and a fourth 10. So we get 156 million for that one. All right. Part C then adds a little bit of a different take to this problem. Part C says the order of the letters is not important because they will automatically be put in alphabetical order. So no matter what letters I pick, like if I pick a B and an A and a D, automatically I'm not going to be able to arrange them any way I want. I can't do BAD or BDA. It's always going to put it A first, then B, then D. So really all that matters with the letters is what letters get picked. So with letters, it only matters which letters we choose. Which is a little bit of a funny way to phrase it, but really at that point then, if all that matters is which letters we choose, then really that would be a group of letters. So we need a group of, well, we still are going to pick 3 letters from all possible letters, which is 26. So really for picking the letter part of the ID card, it's just going to be one event. So pick the group of letters. Then it says the order of the numbers is still important. Neither letters nor digits may repeat. So when we work on this one then, neither letters nor digits may repeat. So then I still have the order of the numbers is still important. Number 1, number 2, number 3, number 4. We still have 4 of them, 4 digits. Those digits can't repeat. So I'm still going to have 10, and then when I get to the next one, I don't want to reuse the same one. So we'll go down to 9, go down to 8, and go down to 7. For the letters, though, to pick a group, we're actually going to use a combination. So we're doing from 26, we're going to choose 3 of those. Now, to put all of this together, we do have multiple events, right? Pick the group of letters, and then number 1, 2, 3, and 4. So then sequential counting says take all of those things and multiply them together. Now, the last part of the question says we don't need to simplify our answer, so we don't need to finish doing all of those computations, but just set up the fact that it's that combination times 10 times 9 times 8 times 7.